Hey guys, continuing on with this little amateur makes an OS series. We have the basic menu filled out that just tells the user if they entered in a command that we found or that we didn't find, or we can end the program. The only thing I did between the end of last episode and this one is I added more comments for like structuring because the file's starting to get longer. And then I redid this slightly to where if it's F, we get the found message. If the user entered an N on the menu, then we're going to halt it in the program. Otherwise, we're going to print, we didn't have a command, boo. But yeah, so all we're doing here is we have our basic menu, which is just a one-liner. If they don't enter an F, they enter in something that isn't F or N, it'll be, something went wrong, oops. If they enter an F, eventually we'll have that go to the file browser. If they enter in an N, then it's going to halt. So we have a halt instruction there on the right, and now nothing happens. So that's all we're doing. So what I want to do right now, at least at the start of this episode, is make another menu thing. I'm going to make a reset, because if the user keeps entering commands on the menu right now, it'll just, keep going and scroll off the screen, as it were. So I want to make a thing to make the screen pop back up. To make like a reboot option, kind of. It'll be like a warm reboot. The CPU for x86 has warm and cold reboots, and as part of that is if the CPU thinks it's been turned off and back on power wise, it'll go to a certain section when it first starts up and go do other instructions, or it'll go to what's known as the reset vector, which is right at the edge of addressable memory. At least for whatever mode we're in. In real mode, it'll be 16-bit, so FFFF would be the limit, right? But the reset vector in 16-bit mode is FFFF with offset 0000, or effectively FFFF0. That's where the reset vector is, so on a warm reboot, the CPU looks at that address. That address should contain another memory address, which the CPU then jumps to and begins executing things on a warm reboot. If it was a cold reboot, such as a power off, turn the power off and back on again to your computer, it'll go to some other thing and execute more things. And obviously I didn't research that one as much because I don't know what it does. But the warm reboot, it just goes to the reset vector, which I think should contain maybe location 7C00 and go to our bootloader and load that stuff. But I could definitely be wrong and probably am, or at least not mainly right. But anyway, I want to add a reboot option to our menu, TLDR. Let's add another thing to our string here. I'm going to put R for reboot. So I can put we'll just do that, reboot. That's all we'll do. And end it with the 0 again. Well, 0A, 0D. Okay, so then we'll add it to our code up here. Compared to F, didn't find. Okay, compare AL to R, be our reboot option. And if it is an R, I guess we'll make another tag and call it like reboot or something. It'll just be a jump, really. I think all we're going to do to reboot is just jump to the reset vector. So we're going to try that first. Can't guarantee it'll work, probably won't, but let's just try it. We'll do a jump for FFFF 0000. So I'm going to put a far jump to reset vector, and we'll see what happens. Jump equal FFFF 0000. We'll see what happens. I want to make them hexadecimal. Duh. We'll see what happens. A little tired today, as you can tell. I had some yard work and mowing and stuff to do. Where is my mind? I like the pixies. Let's make ROS. And this doesn't work. It does not like it. Oh, extra characters on the line. Wow. So we cannot do this. Okay. Well, we're going to make a little other thing then. Instead of doing that jump here, we're going to do it later. I'm just going to go to a reboot code. Reboot, I guess. It'll be a warm reboot, so I'll put warm reboot option, and we'll put it down here, I guess. R-E-B-O-T. Okay. Reboot. Alright, so this code, we're going to put just the jump. that we just did that it wouldn't let us do. And see what happens. Alright, let's see if this does anything. Probably not. Oh, well, it compiled that time. It assembled, rather. It did not compile. Exciting news. We're getting somewhere. Oh, we got those. So R. So let's do like F. And then another. Ooh, it didn't like that. That's not good. But it's working. That's the reboot you're seeing. It reboots the whole thing and goes back to here. So that actually does work. I was going to say it didn't work, but it's because I put it just to here. This needs to be a jump equal. I don't know why I didn't do that. All right, let's end this and let's go over it a little bit better. It is very hard to think at a basic 3rd grade level and talk at the same time and not make mistakes. So a bunch of mistakes will be made, of course. All right. So we have strings here. All I was going to show there, this, I just wanted to do, so this came off the screen and we wanted to get the stuff back. And then later, you know, if we just want a basic warm reset implementation, enter an R for reboot. And the whole thing reboots. Isn't that nice? It's cool. All you do is jump to the reset vector and the CPU's like, hey, we should do our, you know, whatever we did when we started up, let's do it again. The BIOS address, our 7C00 for a boot sector, I think that memory address should be located at the reset vector here, and I think that's why it's doing it, but I'm not absolutely sure. Of course we can find out. And the reason I found out the reset vector in this stuff was because I wanted an option to shut down, but that you need different things to shut down. It's more complicated. You need to talk to like ACPI or other things, and Linux does it, and Ubuntu and everything does it. So I might look at their implementation, try to maybe adapt that if I can understand it. Probably not, but you can do warm resets, reboots like this, so that works. What we can do instead is try to load our, I guess, make the file table menu option thing and do that. So let's try to go to that. So set video mode and everything. We might want to reset the video mode again and do these things just to clear the screen in preparation for showing our file table. So our file table is in our second sector on our boot disk, loaded after the boot sector. The boot sector loads it to memory location 1000. Our kernel here is at memory location 2000, and then it's jumped to. So we want to read what's at memory 1000. We want to read that, which is just a string at the moment saying what programs we have. We want to put that to our screen. We can add some more variables for that as well, but let's make the actual code first, I guess. I'm trying to think of a way to like structure this better, because right now this looks like crap, you know, but oh well. I can structure it like the menu options, which I guess is what we're doing. Let's move all of this after the program ending thing and hope it still works. It should still work. I just want to separate this out because this isn't mainline logic here, what we're doing. This is the equivalent of like a subroutine or procedure, so I'm going to put it after so I can make room for our menu options. This is a menu option. Menu R, menu in program. Okay. Menu F, file browser. Well, what did I call it? File and program browser loader. Okay, I'll just put file. All right, so F will jump to this. Okay, F, let's jump equal, it'll be found. Let's change this to, oh, we're just gonna get rid of this. Instead of going to there, let's call it file browse. We'll just call it file browser. File browser, yes. File browser. Okay, now we got our thing set up. All right, so I'm gonna reset the screen here, so let's get this stuff. Oh, here, set video mode. Okay, so I'm gonna reset the screen pretty much. Put it there. Okay, so we'll reset the screen first. I do want to switch to graphics modes eventually, but at the moment we'll just do text mode here for now. So after we reset our screen state, if anyone has better suggestions for, you know, laying out, structuring the source code within a file, let me know. This is just what I'm, you know, doing now. Obviously spending too much time on it, but, you know, I gotta make it easier for myself later, right? So after we reset the screen state, I want to load the string from the file, I guess, and show it on the screen. So I'm going to do load file table string. Let's call it that. Load file table string from its memory location, which should be hex 1000. For starting out right now, let's just load the string that's in there. Did it end with a 0? I don't remember. Did I end the string with a 0? Because then that would make this easy. I defined by, well, I did zeros after. I did zeros right after it, yeah, so we're good. We ended it with a 0, okay. Because I'm gonna just move this, I think, into SI and call print string, and it should be okay. So let's just do that. Let's move into SI. Can I move a memory location directly into this register? I don't know. That's a good question. I feel like I can't, but I'm just gonna try it. File table location to, you know, to SI. Our source index register. And then since we're using SI in our print string, I'm gonna call print string. So let's see what this code does. Probably nothing, but I don't know. Let's see what it does. Well, at the moment, after it calls it and returns, it's going to go there. So after we call this, I'm just going to halt and catch fire. So let's go back to our shell. Let's make clean and OS again. Okay, that's a good sign. No assemble errors. However, when we run this, so R should still reboot. Okay, J is oops. But if we went to F, it does clear the screen, but it's not printing anything. So our memory location 1000, I guess, is not good. Doesn't have stuff in it. So that's good. We found that out the nice hard way. So we can move memory into there. That might just move the number into there. I thought it would move the address. Maybe not. Okay, so I found a way that does work. I'm not completely sure why this works, and just moving a regular location into a thing doesn't, but it looks like for memory addresses or something, I don't at least to move them into here and use them as strings and such, I need to use like segment register and use offsetting like this, use the memory address and the offset. So what I did, move the location to AX, move that into EX, and then, you know, zeroed out BX here, and then just to print the first character there, I moved ES memory location 1000 with the offset BX, offset 0. Move that into AL for that character contained at this location. Then I'm printing it, and this seems to work. I don't know why I can't do it, you know, a simpler way, but apparently to reference that memory, I have to use, you know, segment and an offset. So anyway, I'm not going to worry about it. I might try to simplify it later, but this works for now. So if it works for now, then we're good, right? First character is the bracket, which that is right in our file table. First character is the bracket, so we're good. So we can, you know, get on with our merry way here. I'm hoping that I can just move it into SI and call a print string here, and that will print our whole string starting in SI. I'm hoping this will work. It might not though, but let's find out. Let's see if this prints the whole string or not. I'm gonna have to make some more make commands here because I'm tired of typing this every 2 seconds. These 2 or 3 commands just to restart. Might make a thing that's like make restart or something. Okay, so it does not work if I move it into SI directly. x86 has some quirks that I have not figured out yet, which is good or bad, you know. Could make a guy go crazy, I don't know. So AL is addressable from that byte, but not SI. Well, that's annoying, isn't it? Load SB loads AL into SI. Is there a command for string bytes to like load a character from a memory location into SI? Is that a thing? Okay, well, I don't think I can do what I'm asking for here, but I can do this. Move it to a register. Can I move this to a location and then move that location to SI? Can I do that? And by location, I mean like a variable like this, command string. Let's see if this works then. If we can do this, can we move it to an arbitrary thing? Can I move it to command string? Let's see if that works. Maybe not, I don't know. Oh, that's allowed. Okay, so this would contain that memory location. Okay. Well, this would contain the character there. Well, I mean, I can just move into AL. If we can move that into AL, move into SI. AL. Oh, file table loop. Alright guys, so what I did was, first of all, I made a file table heading that'll just say, file program and sector, where we put the file program and sector numbers that we're doing. So it'll just say calculator, some spaces, the 4 for the sector number, so on and so forth for every one of these. I got rid of the space in there to make it more consistent with printing them out. And then this is a little involved, not too much though, but annoying. Well, that's all right. Anyway, before I get to this, we're printing the table heading. Okay, so I'm using a counter that's going to count. I'm using CX as a counter, a CS register to count how many bytes are in this name, the length of it pretty much. That's what I'm doing there. The length of each program or file name putting into CX. I'm moving the location of the file table, which is, hex 1000 into ES, BX. I'm zeroing out with XOR, which I'm using these for these because I was reading and it said that was a faster way than moving 0 into a register. You can exclusive OR it and it'll make it 0 pretty much. That's a good way of zeroing out a register, and it's faster, I think, for the CPU. So I'll be using that more in the future. 0x0e because I'm going to be printing stuff out to the screen with int 10. So we enter a file table loop. Okay, so I go to the next character by default in every iteration of the loop. So the first time it'll go to the C here for calculator. We're going to move the character at, 1000 and then hex 1000 plus 1 to go to this. That character at this memory location will be moved into AL, comparing it to the right bracket, which will be the end of our file list here. If it's not at the end, if it is at the end, we'll stop. Right now I'm just halting. If it's not at the end of the list, we're going to see if we're between the elements, which is the hyphen, the dash here, between the file name and the sector number. So when we get here, if we're not in between, we're just at the name, we're going to keep going. We're saying I'm going to check for a comma, which is in between the elements themselves in this file table. So calculator, comma, program 2, comma, program n, whatever. Then we go to the next element. If we're not, then we're still in the name here. We're just going to increment our counter. So, there's one character in this name. We're going to print out whatever that character is, which is an AL. And then we're going to loop again. So that'll print out the whole name over time. When we get to the hyphen, the first thing we'll get to, we'll go to the sector number loop here. We're going to compare. 21 is kind of an arbitrary thing, but it was just to get the spacing right for what I'm using right now. If we're not at 21 length, I'm going to basically just print spaces until we are, and then increment CX till we are at 21, just to line stuff up right. But after we do that, we're going to go back. Once it is 21 and the requisite number of spaces are printed out, I'm going to assume the file names are going to be under 20 for now. I'm going to raise this later, of course, and change and do something different. But right now, I'm assuming all the names of the files will be 20 or less. But anyway, after we print out the name, we're going back. We're going to increment again, and that'll take care of printing this out under the sector heading here. See, I'm putting the spaces here. I put 21 so it fills up this, and then the number of spaces to make it look okay. And then it'll print out the sector number, which will be 4 for the first one. And then when we get to the comma, we go to the next element, and all I'm doing here is zeroing out our counter again so that we reset for the number of characters in the next file or program name, and then I'm just printing a couple new lines and then going back. So that's all this is doing. And once it goes through all of these, reaches the end, the right bracket, we're going to go to stop and we're going to halt. So that's all this is doing. But it looks, kind of fancy. Things are more involved, as I'm learning with assembly here. Simple things are more involved, but they're not too bad once you get used to it, and it helps me learn more. Just to be sure that it does work, and it should, but here we go. File program browser. Oh, that looks different. That's all right. Anyway, but you can see where I was trying to do this. Under the file program, it should have calculator and then the sector, and it'll have this, a couple new lines. So it'll do all that. I wonder why it's printing like that, though. Did I mess this up down here? I probably did. Oh, I didn't put a new line after. That's what it was. I didn't put a new line after this. That's all it is. That's all that is. Okay, so we're gonna cancel out of that. I'm also gonna look up a way to get, you know, in the regular terminal, you can just press like up arrow or whatever for your bash shell and it'll get your previous commands. I don't know a way to do that in Emacs. I'm sure there's an easy thing, I just haven't looked it up, but I need to do that because that would be also a time saver using this shell in here. All right, so that's what it's supposed to look like. See, there we go, file program. So that'll print out for however many elements that we have in our file table, expanded out as we go along. I won't have too many to start off, but eventually I will. And eventually I'll need a better implementation than this simple thing, but this works for now. I think it works pretty well. Okay. So the next thing I want to work on for this is being able to have some sort of a selection to select this, either highlight the line or have like a thing to select or whatnot. So highlighting the line would be interesting because I'll have to get the cursor position and move it up, and I don't know if I want to do that before going to graphics mode. I might just move to graphics mode and deal with that. We'll see. Anyway, I'll get to that on the next episode of this. I've gone far too long. That's all right. Thank you all for watching. I'll see you then.